Hello, it is a huge pleasure to be here today at the Shanghai Maker Carnival. I'm Christina, co-founder and Chief Innovation Officer of Wikifactory, and we're hosting today at the Maker Carnival a very important session about how to future-proof your career as a maker. I am so well surrounded today because we're going to be welcoming a series of speakers. Each have been pushing their maker skills into new innovation areas that are extremely exciting because there's an opportunity that we want to highlight. We believe that digital fabrication skills, whether learning about 3D printing, CNC, laser cutting, really is a gateway, a means for you to extend your knowledge into new exciting innovation areas that have a role to play in our future. And that's exactly what we want to shed light today. Because whether you're a pro or just getting started, there are so many projects, open projects, complete with files, documentation, the means to engage in feedback with the creators so that you can really practically get started and deepen your knowledge in these innovation areas. I will be welcoming the speakers. Each speaker is given 8 to 10 minutes to share their experience in taking their maker skills to these new innovation areas. And then we'll wrap up and actually look at the ones that aren't covered by our speakers, but equally can be a path for you as a designer or an engineer or a product innovator. The three speakers that we have here today is, on the one hand, Camilo Parra, who is the founder of OttoDIY, probably the most remixed robot out there, incredible project. And we also have Saverio Silli from Fablab O Shanghai in Shanghai, who has been doing some pretty amazing work at his Fab Lab, inspiring members in new machine innovation. So I can't wait to hear his contribution. And not least, also Agustin Arroyo, who's a very well-known product developer around the world, quite the influencer, but he will be sharing to you how he's been engaging his skills in new innovation areas as well. So without further ado, I would like to introduce our first speaker. Camilo, it is such a great pleasure to have you here today. Do let us know how you were able to extend your maker skills into entering the field of robotics, which is the perfect one to start with, because digital fabrication is in and of itself a technology that's empowered by robotics. So I think OttoDIY, for those of you who have never tried robotics, is the perfect place to start. Over to you.
Thank you. Thank you so much for the great introduction. I'm very excited to be here. It's like a little nostalgic because I participated in many Maker Carnival since 2016 when I was living in Shanghai. So for the ones who don't know me, I'm gonna tell more about my background and what I did when I was living in Shanghai, because now I'm living in Czech Republic in Europe, where I continue my maker career now as a business. So that's why I think could be a great inspiration for many people to make that jump from the maker person to a maker business or maker pro, as many call. I'm gonna share my screen so we have more visual support here, and you guys can see what I prepared. So this is Auto Robot. Many know me just for Auto Robot, but before getting to Auto Robot as many maker, you get to know to make a lot of projects, right? So actually I started Auto in 2016, but back in 2014 when I moved to Shanghai, I was working for a company that was doing inflatable products, and I was working full-time as an industrial designer. But they didn't have 3D printers. It was not such fun thing. They always outsourced the fabrication of the prototypes. And I really didn't like that. So in my spare time, I was spending time in the hackerspace in Xinjiang or the Mushroom Cloud in DF Robot, even in the Fablab of the Tongji Dashway. And then I met great people, and that's where I started to learn robotics, because I am not a robotics myself. So I learned robotics, I learned Arduino, I learned 3D printing, and you just get involved in that world and you start to like then buy a machine, buy parts in Taobao, you know, for your prototypes. And sooner or later, I mean, 2 years after, I finally launched my own thing. But before that, I did a lot of designs. One of the things I want to show here is that the robots on the top were designs that I thought as a designer, industrial designer, I could make. They look nice, but in real world, they didn't work, because once I start to make them, I start to learn a lot of things by making. And only until like the latest one, I started to really make sense of like the logic of building a robot and the mechanics involved and the process involved to really make the prototypes work, the coding, the mechanics, the electronics. And only when you really combine all these skills is that you can really start to make things reality. This is a nice picture we have in one of the events. This is in the DF Robot Makerspace Motion Cloud with some of our friends. So like, yeah, you get to meet a lot of international people in Shanghai also. It's about the community most of the time. So that was one of the like great support. I mean, many people think that I was the one that really created everything because I'm in the face, but it's always a community work when you are a maker. Then I decided that there was a need for a kit or like a robot that anybody can build, because even myself as an engineer, I couldn't make a robot. I mean, I was not able, and I found out that the obstacle was in having the right materials in front of you, the right tools, the machines, the technology, or the knowledge for that. So once I figured out that if that is in one package, then it's very easy for anybody to build a robot. And that's where I started to build around the idea of build your own robot. The idea that anybody can make their own robot and learn about technology, and in a fun way, right? It doesn't have to be like the theory and boring theory that you learn even in the university, but like doing a robot, you learn a lot of things, not only robotics, but technology, design, coding, and more. So many of the ones that don't know Otto maybe don't know what it does. So Otto basically, in the basic form, is this robot that I have here, and it can walk, dance. You can program, and it can avoid obstacles with the ultrasound. It's 3D printable, open source in both software and hardware. So we now have a block graphical programming. So even the programming is very easy for beginners. But of course, we didn't stop there. One of the things that we saw once we launched it is that many people started to create their own variations, also myself. So we start from the bottom, but now we have, like the one I have in my hands have Bluetooth and you can control with the app. We have other ones with LED eyes made with laser cut. So we didn't only limit by the process of the 3D printing. Then we add arms, LED mouse, and other features. And we see it as a progress way. Some people like to jump right away for the complicated humanoid, but we see it like that could be a progress, like learning curve for people to learn more and more advanced stuff in robotics. And it's still the starting point is the small robot, Otto. Right now, we have a community of more than 4,000 members around 70 countries, thanks to the open source nature of the project. One of the challenges we have was the documentation. So like in China also, in Shanghai, I met the team of Wikifactory when we were like having all our documentation in GitHub, Thingiverse. It was a mess. And then we really meet the team of Wikifactory. And since then, we have been attached to them all the time in terms of documentation and even additional events and challenge that I will show you soon. So just to finish, like the part of Otto is that we also encourage people to create their own variations, because we see this as a white canvas for people to start also put their creativity to the limit. I mean, not only learn about how to build it, follow the manual, but similar like Lego does. Yeah, you follow the manual first, but then you add your own twist to it. With Wikifactory, we created this great challenge last year, and that inspired a lot of people to create their own remixes, as we call it. Right now, there's more than 100 remixes, maybe more. I mean, maybe 200, but these are the ones that we see in the platform and are connected somehow in Thingiverse or even in other ones that we still need to bring them out, because all the time you see people creating new stuff. And more than 25,000 people have replicated the robot, as long as we see in more or less in the statistics of the number of downloads and all the posts that people do in social media that they made the robot. This is a short video of like that can present a little bit the process of how the robot is made. I mean, it comes in a kit, right? And then you just build it from all the parts that you have. You have everything. You have the screwdriver even that you need to build it. You have all the plastic parts that are made on the 3D printer, and even the thing to hold the batteries, right? The battery holder. It's an Arduino compatible kit, so like it can be programmed with Arduino, of course. And the good thing is that, yeah, you can 3D print, so that you can decide what color you wanted. I mean, the first kit we showed was a builder kit that already comes with the 3D print parts, but people can like decide not to and just get the electronic parts. Here is like how you program it with the Blockly that we also created, and it's open source based on it's AutoBlockly, but it's based on the Blockly graphical programming language of Google. And we made also like a remix of the software, so like it can be dedicated to Otto. And right now, here, this is the app. We also develop an app that is also open source and allows to make the basic movements of the robot. And you can even have some little sequences. This is something that we are working on. So I'm revealing some hidden things, and it's more into tangible programming. So we are towards now a new era of like even 4 years old kid can learn how to program. This was the winner of our Auto Remix Challenge. So it was an auto drawing bot that it was made by one of the members of the community. And also in China, we saw many people creating remixes when I was living there. This was Pando by one of my friends in Hangzhou. And you see all kinds of creations. You hear here Harry Otto, the spider one. So it's really like depends of like what people really want to do. We are also working on a new version that we maybe want to mass produce. And here you will see a little bit pictures of the event we made with Wikifactory in Spain this year. We made a workshop. Unfortunately now, because of the situation, we don't do more workshops. But this is something that we were doing also in Shanghai a lot. That's how I started also doing workshops to like include people into the making. So now we are even like thinking in having a more modular robot that can be assembled in different ways with the same parts. And that's like kind of like what the next step of the project. Another new thing that I wanted to share today is we are having our own educational platform that we call Otto Academy. And basically it's to gather all this knowledge that we have been always putting out there, but not really in a format for schools. And now we are organizing it into courses and different learning experience with even our new Auto Scratch AI. So you saw Blockly before. Blockly is more like the interface is more like the old one, let's say, and Scratch is very popular in schools. So now we are working on the Scratch one, and we added AI into it. So like the way we are adding AI into it is like you can have, for example, face recognition, you can have voice recognition as well, and even pose detection with the robot. And somehow like what we do is that we connect it to Watson. assistant that is by IBM. So like you interact with the cloud that has all the AI, and the AI sends the interactions to the robot. So this is something very cool that we are already demoing in the last month. And we hope that we can create also a learning experience with this in our new platform to learn about artificial intelligence, design, engineering, coding. So that's how the three areas that we want to educate people now with our kids, with the robot, so that they can not just limit it to the building part, but also to all the learning behind that somehow I had also, or through the development of the robot, I had to learn, but now in a conscious learning system. So thanks for your time. Yes, yeah.
Thanks.
Hope you like it.
Amazing. Really, what an incredible learning curve, like you put it. For anyone who's wanting to start in robotics, there's no doubt that it offers an opportunity to even the less amateur, someone who is actually quite involved in robotics, can, you know, really play with OttoDIY in any new sensor that comes out in the market, right? If there's any new sensor electronic component, well, it's what a great sandbox that OttoDIY provides. And I think this now really nicely connects to our next speaker. So we have here Saverio, because fundamentally, if the idea of innovation in robotics is actually the birthplace of digital fabrication machines themselves. What is not a 3D printer, a CNC, a laser cutter, if not a tool connected to a robotic system? And whilst we have, the maker movement has been born out of the hype of the 3D printing movement, you could say around 12, 15 years ago, it's not just 3D printers and laser cutters that this market needs. I would say that there's a whole range of machines that still could be digitized. And the work of Saverio points exactly to this. I think this is a future-proof career area. There's so many machines that we still need to develop. So here's to your story, Saverio. Thank you so much for joining us.
Hello, thank you for inviting me. Let me share my screen. Okay. Okay, so let me start here. Okay, so a little bit of an introduction about myself. So I am, my name is Saverio Silli. I'm an architect. I studied architecture and I work as an architect. Now I am the vice director of the Fablab O in Shanghai, and I also work with Tongji University. Actually, I worked for a long time as an architect and interior designer in Rome until the maker movement appeared in Italy and exploded in Italy, and me and other people in Italy, we were among the first people to start and to bring the maker movement in Italy. I opened the first Fab Lab in Rome, and we organized the first maker fair in Rome. And then I decided, okay, I have enough of designing, making interior design. And what I really like is working with my hands. I'm a maker. So I joined the Fab Academy, which I'm going to introduce a little bit to you. And after that, I moved to Paris first to teach this class. And then since 2017, I'm in Shanghai, where now it's been almost 4 years. So this story is a story about bits and atoms. So you start from the computer world, the information world, and through digital fabrication, you can make real things in the real physical world. You do it in a Fab Lab, at least that's where I do it, in the Fab Lab. The Fab Lab means fabrication laboratory. It was started by Professor Gershenfeld at the Center for Bits and Atoms at the MIT in Boston. So again, bits and atoms put together, digital fabrication. These Fab Labs are a place where all these machines you can find all digital fabrication machines, and they are so successful that there are more than 2,000 Fab Labs all around the world now. In MIT, Professor Gershenfeld teaches a class that is called How to Make Anything. This class is open to every year to 15 students that are enrolled in the MIT. But Professor Gershenfeld thought, what about I open this class to everyone that wants to join through online teaching and offline inside of each Fab Labs around the world. There are so many Fab Labs that are all connected in a network. And so the same class that the Professor Gershenfeld teach at MIT is also taught in Fab Labs, and it's called Fab Academy. And this is the class that I took as a student, and that basically changed my career and changed my life. Sorry. This is the way it looks when we are all connected in this virtual classroom. Every Fab Lab is a local classroom of this network. Inside the Fab Lab, you learn by doing. And so this is really the basic of STEAM and STEM education and project-based learning that is now so popular. It's hands-on experience. You have all these tools and these machines, and you have a project every week in which you have to make something. So you learn how to use all the machines, the laser cutter, you learn techniques like molding and casting, you learn how to 3D scan and 3D print, you learn large format machine like a CNC router that you can use to make, actually the table I am sitting now is made with one of these machines. You learn how to design and make your own electronics. And as you can see in this image, in the bottom left, there is my name on this PCB, and you see that LED. When that LED shine up, I was so happy because that's the first thing I've ever done. I came from architecture and I knew nothing about electronics, and I was able to shine an LED. It was the best day of my life. You also learn, of course, a digital fabrication machine is nothing without knowing how to design and how to make the file that then you're going to send to the machine, and programming also as well. And this was my first try at making a machine that is not a 3D printer or a laser cutter or a CNC machine. It's a machine that is made with these machines, but that makes something else. In this case, this machine was a machine that makes Zen gardens. So there was an actuator drawing in the sand and drawing a garden in the sand. Actually, this was sugar rather than sand because it was easier to take a picture of it. So Fab Academy is a class that is taught in Fab Labs around the world. I am the local instructor here in Shanghai. We have been doing it for almost, for 4 years now. We're going to start a 5th year in the next semester. Is a digital fabrication course delivered through the global Fab Lab network, in which students make 18 weekly projects and 1 final final personal project. So I want to show you a little bit of the final project of Fab Academy. This was a drone that could avoid obstacles by Daniele Ingrassia. This is a beautiful machine from Enrico Bassi. It is a portable CNC machine. You actually don't need a big machine that sits on the floor, but you attach the machine to the wooden board you are going to cut. another multi-tool machine by Gianluca Pugliese that you can change the actuator. It can be a pen, a marker, it can be a little router, and you can put it anywhere you want, on the floor, on the wall, and so on. A photogrammetric scanner, so it's a machine that is used to take a precise 3D scan of an object while this object rotates, by Pierluigi De Palo. And then finally, the machine that I made as a student in Fab Academy, a rotational casting machine. I have always been in love with molding and casting, and so I created a machine to help me make better casting. And my aim in this in the design of this machine was to make something that could be designed, created, fabricated in a Fab Lab with the machine you have in a Fab Lab. It features a different, it's not a new invention, but it features a different way it works with, it's like a very big ball bearing. So I made all the design of this machine, and I find a way to fabricate it with the machine that I had in the Fab Lab. This was the first attempt at cutting a piece of MDF. In this little video, you can see there is a mix of techniques here. There is 3D printed gears, there are CNC machine wood, and then wood that I just cut with a handsaw. And the idea of this machine, while it rotates in one axis, it also have an additional rotation inside of the machine. This is the design that I made for cutting the machine from a CNC router. As you can see, it gets a little more detailed here. And this is the image of the panel, the wooden panel cut. I made more, I really limited to the least possible the things that you have to buy. You only have to buy bolts and the steel ball. And most of it is 3D printed. So to make this machine, I used the laser cutter, the CNC machine, the 3D printer, and I also designed my own electronic. This is like an Arduino, but it's made by myself, and it only has the functions that I need. Not all the pins are available, only the one that I really need for this machine to work. And this is a little video of this machine working. You insert a mold inside of the machine. Then there is an application that you can use to control the movement. And then these things rotate. And after a little, like an hour or less, depends on what material you are using to make a mold, you can stop the machine and you can open it and remove the mold. Inside of this mold, here I am opening it, and this object that you see inside, it is hollow. So the idea of this machine is to make hollow objects. So what I want now to, my story ends this way. In my opinion, documentation is the foundation of open source. I decided to release this project in an open source license. I wrote a long documentation on a website. I took screenshot of all the settings of the machine I was using, what tool I was using. I made a bill of material and everything, and I released this project as open source. I even uploaded it on Wikifactory. And it is open source, ready for everyone to download and use. And I also had some problems. This machine was just the first prototype, and it had a problem that the rotation was not so smooth. So I said, okay, I have this problem. I will come back and fix it. And then something happened and life goes on, and I moved to another project, and I never went back to fix that problem. until I receive an email and a picture from these three guys. This is one teacher in a high school and two high school students. They found my project online, they read my documentation, they liked my machine, they made their own version, and they even fixed the problem that I discovered, and they used their machine to make chocolate eggs. So chocolate eggs that are hollow inside. This is a very famous dessert like thing in Italy for an holiday. And when I received this email from them, I was so beautiful. We even met at a maker fair in Rome, and we put these two machines together. And then I downloaded and printed the part that they fixed, and I updated my machine. So because of an open source license, I was able to have basically research and development and fixing problems, debugging made by someone else for free. My story ends here, but I want to show you my page on this project on Wikifactory. And one last thing, I don't know if the video maybe is not so detailed, but this is the last project that I've been working on with my students. It is a machine, but this is a pizza cutter. So you can make a machine that does not make much, does not change the world. This machine cuts pizza. It was maybe for fun, but this is the kind of project that we like to work on. So once you learn how to make a machine, you can learn many of them. This was during the Fab Academy presentation in the last semester. This is it. I can stop sharing. I hope you enjoyed my little story. And if you happen to be in Shanghai and you want to come take a look at Fablab O, we are always open.
What a great story, Saverio. I loved it. So true. So clearly, thanks to good documentation, not only can others like yourself learn the projects, but you can also begin to contribute and remix on the projects, whether it's OttoDIY, whether it's on the RotoCaster. This is what it's about. You can take reins of your learning and contribute to these incredible innovation areas. I'm going to take one quick moment because this is the cue. You mentioned OpenStage, you mentioned the S-Mill. They're also part of this collection of future-proof learning projects that we'll be sharing through our QR code and through the link provided. And if you click through, it will take you to this great page that has all of these projects. It includes OttoDIY, of course, and the RotoCaster. There's a whole ton of projects. They're all very well documented. So all the documentation here, this is a centrifuge developed by a team over in Thailand with all the files. You can click through the files. What's neat is that you don't have to, well, here in this case, they've shared in STL. It could be that they shared in SolidWorks. It doesn't matter because on Wikifactory, you can open it up and view the files directly. It's taking a moment to load. And you can even actually comment, ask any questions away to the project. If you have ideas on how to improve it or have a problem in any step of the way, you can open an issue and ask the project creator directly. This is what becomes possible thanks to the contributions of OttoDIY, of RotoCaster. And this is the future of learning, and this kind of cues in just right to our next speaker, because all of these projects highlight that there's an opportunity, whether in learning in robotics. Let me show you. We've got projects in robotics, so a spider project. You know, there's project around mobility, furniture design, biomaterials, sustainable tech in building your own turbine, your own It can even be consumer products like making your own speaker, because there's a quite exciting developments around music in itself. You can learn how to recycle material to make your own electric skateboard. There are so many projects that you yourself can learn from right now and future-proof your career. But beyond all these product innovation areas, to loop in our last speaker, Agustin, it's not just about potentially sustainable tech or biomaterials. There's a future in education. Education will always play a role in our society. And I love Agustin's story because whilst he's an incredible product designer, he's actually carved his path in the education market so that others like you can really go deeper into that career path and start shaping it. So over to you, Agustin. I would love to hear your story.
Well, thank you very much to Saverio and Camilo for sharing your stories. They are certainly inspirational, and in the end, I believe we all share a common story fueled by creativity and curiosity. So I will share my screen. I prepared a very simple presentation focused mostly on what have I done during the 17 years I've been living on this planet so far. And basically, I was born a maker. That's one of the main things I need to address. However, I didn't realize I was a maker until I was, I would say, 23, 20 years old. So basically, it was 1993. I was born in Argentina. But I started cultivating that curiosity towards product design since I was a kid, disassembling all the electronic devices I could find. That's something maybe Camilo and Saverio you can relate to. Like, how does that work? You learn, what if I change that component? In 2010, I decided I wanted to study design. I didn't choose architecture or engineering. I decided I wanted to focus more on the visual effects and on graphic design. But in 2013, as it happened to thousands of makers out there, I discovered 3D printing, I discovered laser cutting, and I discovered a massive community. And I started, I got my first 3D printer, I started making on my own and learning on forums, on social media, and individual makers that simply wanted to share their projects. Thankfully, I fell in love with the community, and after years of making and learning on my own, I had the chance to start sharing all that knowledge. I became an educator in a social Fab Lab in Spain, in Technolab, where all those young teenagers that didn't know about 3D printing could play with that technology, learn how to use it, and have access to the technology. And in 2018, I had the biggest opportunity in the Universidad Francisco de Vitoria in Spain, and I became a university professor teaching 3D printing to architecture students. So we are not talking about real product design or the product design most people have in mind. It was just people realized that the maker skills and machines could be useful in different environments. And then in 2019, I launched my first online course. And basically here, this was a really important moment in my life, because 3D printing became mainstream, and all the things that the maker community had been doing, there was a very big platform that said, okay, now we want to share all this knowledge, or at least small bits, and we want you to gather all the things you've learned so far from this community, try to package it up as well as you can, but it's not perfect, and share it with the community. What I want to say is that all makers, no matter where you start and where you come from, share a common path. I started being a curious designer, then I discovered 3D printing, and I became a maker. And I could say that the moment I discovered the maker community, I started learning like I had never been doing it before. As one thing, what Christina mentioned is that on Wikifactory you can find tons and tons of projects made by makers, and that's probably the best way to learn, by making. You can read a book, you can watch a video, but you won't start understanding. You prototype on your own. But as you can see in this small ladder, I became an educator, then a university professor, and then an online. And the common thing is 3 areas is that I started doing what I had learned from the maker community. My story as a product designer can be described as learning, making, and sharing, those 3 simple steps. For example, now as a content developer on Wikifactory, my job consists on supporting those product designers, those Fab Academy students, those users trying to remix Otto. For example, I had to design an enclosure for a Game Boy card flasher, and I wanted it to be nice. Well, everything I learned from that experience, I transformed it into an article, a small guide on how to design an enclosure for your project. I started being a maker, I tried something, I failed, I learned, and now I'm able to share it. The same with bill of materials, because Camilo, for example, he needs to have a very specific list of materials you need. And when he created the Otto kit, he made a box with all the components because he understood that getting all the components from different suppliers would be a nightmare. So you can see with Camilo and with Otto that having a bill of materials is one of the crucial aspects of product development. Then how to choose the right materials, because Saverio will know in the Fab Lab that not all materials have the same properties. We can think about laser cutting, we can think about 3D printing or CNC machining. Well, in my case, I learned about it creating a social product, a small airplane that was the key element in a fundraising campaign. Then we have how to design for assembly, because I tried being a YouTuber and I learned that designing something that is easy to assemble is critical when you are going to share it in an open source way. And here I wrote a guide on some of the basic tips on how bigger product design companies are actually implementing it during their product development process. Then we have efficiency when prototyping, because most makers, we do this on our own. We are hobbyists, and we need to learn how to make sure that when we move to the next step, all the previous concerns and risks have already been addressed. So basically, and just to wrap up my presentation, I want to say that sharing your projects is as important as developing them. I think most makers, experienced makers, will agree on that. Documentation is a key aspect, collaborating with the community also. And now that we are talking about open innovation, I want to say that the more the product design and maker communities know, the better they are. Keeping your ideas for yourself may be useful if you have a commercial approach, but even if that's the main reason why you're not sharing it, I think we can all agree that involving the community is a very important step when we are trying to create something meaningful. And the last thing is that, as you've seen, hard skills like knowing how to use a machine, or how to document a project, or how to transform it into a commercial product is really, really important. But product designers never, you always need to understand that soft skills are what really make the difference. We are creative, we are experienced in collaborating, we adapt to the materials and machines we have. We are self-motivated because normally there's no one behind us telling us what to do. And the fifth and most important one is that we are a very committed community. We like sharing, we believe in how we are doing things and what we want to achieve. And yeah, just my last words, I'm really proud of being part of the maker community. Saverio, Camilo, Christina, Wikifactory, you're some of the best examples. You need to check all those projects because we'll be really inspired. And thank you very much for the opportunity of you've given me by sharing all my thoughts and ideas.
Thank you,
Agustin. Thank you very much.
What a lovely way of tying it all together. Just to say that this is exactly, you all demonstrate exactly what I hope to highlight today, that really there's no barriers to participate in your learning thanks to these resources of OttoDIY, of the Rotocast, of everything that's been shared by the Wikifactory community and at large on the web, because it offers you a way to tailor-make your practical learning curve, whereby if you're just getting started or wanting to perfect your practice, you can take reins of it. And granted, even if you might not be starting your own project, these are the skills that are highly sought after. Industry knows and speaks of Industry 4.0, and one of the limiting factors in bigger companies' developments is lack of skills and knowledge by their employees. So if you know and you deepen your knowledge in how to use these machines and how to extend it to different domains and disciplines, you will become more attractive in that hiring process, in that opportunity that Industry 4.0 is opening up as a path. For granted, I hope that in hearing the stories of those who have done their own projects, that you ultimately think of making your own, because that's super exciting. Ultimately, I do think that the future is not about closed innovation teams working isolated from the rest of the world. I think the network, the online technologies that we use today offer an opportunity to tap into the expertise and the know-how of a broader network. It's as if given enough eyeballs, all problems are shallow. There's not a problem too hard or too complex. In fact, this is what open innovation allows. You can share a project and work with the whole internet as your distributed team, so that if you meet a stumbling block in that process, others can help you. This is what is super exciting. I hope that you are inspired as much as we are to take that path. And thank you very much, first of all, to the speakers for joining us today, for sharing your experience, and for all of you watching today. Please do check the QR code, the link provided. It will link you to all the resources for you to get started or get deeper. Thank you.
Thank you.
Thank you. Thank you.
Thank you.